Welcome everyone. Now we are discussing lab 5. We are going to solve these 4 problems. Problem 16, 17, 18 and 19. Problem 16 all about program to delete the characters at indices divisible by 3. So here what we are going to do, we are going to input a string, ask user to input a string, and we will find out the length of the string. Look at this. So text input, enter your string. By using length function, we are going to find out length of the string, and this for each index we are going to check. If the index is divisible by 3, then what we will do? We will drop the characters. And index is not divisible by 3. Look at this here. Index not divisible by 3. If this is true, then we will keep that character and add that character to a new string. Now we need to define a new string for that. So we are defining here new text as a blank text. And here whichever character is getting criteria by that, which is not divisible by 3, that is added to the previous string. That is called as string concatenation. Right. So once again, we are asking the user enter your text. We find out length of the text. Now every third character we want to drop. Now when we say every third character, remember that in Python indexing begins with 0, right? So we want to delete the characters at indices divisible by 3. This is the title of the program. So now we check for the index. How long you have to check? We have to check for the index from 0 to length of the text. Length of the text will give us total number of characters in that string, right? And if the character is not divisible by 3, then we keep the character in the new string that is being created as the blank string to begin with, and we loop this for the entire length of this text, and this is how we find out now the final text. And here we are going to print the modified string, right? So now let's take the input as chocolate. So you enter the program, enter chocolate. Now look at this. Position of C index is 0. Now here index, this will be removed. H1 we will keep it. O2 will keep it. C3, 3 modulus 3 is equal to 0. So 3 modulus 3 is not equal to 0 is false. So this C will be removed, right? O is equal to 4, we keep it. L is equal to 5, we keep it. A is equal to 6. Index of A in the word chocolate, index of A is 6th index, right? Look at this, 0, 1, 2, 3, 4, 5, 6. Now this is divisible by 3 and therefore we remove it. Then we go for T. 7 is not divisible by 3, we keep it. E, index is 8, not divisible by 3, we keep it. And thus now we will get the result HOOLETE. This is the new string, right? Similarly you can do for pineapple, so on and so forth. Next we will see slightly easier program 19. Very easy program. Program to calculate time difference in seconds. So you ask for the first time in hours, minutes and seconds. That is the first timestamp. Then you ask for the second timestamp, H2, M2, S2. Okay. Now what we want is, we will convert the first timestamp into seconds. So how we will do? Whatever is hours, we will multiply by 3600. Whatever is minute, we will multiply by 60, and we will add this. Whatever is seconds of the S1, we will add. So this will give time in seconds for first timestamp. Okay, so let us see here. So time 1. So this is how we got H1 into 3600, M1 into 60 plus S1. So this is the timestamp in second, first timestamp. Similarly we got for second, and we calculate the difference and we print the difference in second. Okay, so this is very simple program. That is program to calculate the time difference in seconds. Now next we come to program 18. What is program 18? Here we are playing a game that there are n number of pins. Pins means the small rods which are standing. You are keeping them standing, and you throw k number of balls. Okay, And by throwing first ball, certain pins are deleted, they will fall. By throwing second ball, certain pins are, they will fall. And finally, what you want to know is how many pins are still in a standing position. For a pin to be standing, we will say 1. For pin which is knocked down by the ball, we will say 0. Right. So now we ask these two variables, input number of pins. So say there are 10 pins that we are going to input, random. This is, you can have any number, but we are using 10 numbers, 10 pins. And input number of balls to be rolled to drop the pins down. And we are saying 2. So n is equal to 10 here, enter, k is equal to 2. Now what we are going to do, we are going to create a list having all the ones, because how many ones? Number of pins. But how many pins are there? N pins are there. So therefore, we are going to have a list which is having n number of ones. In this case, n is equal to 10. So now we will have 10 ones standing. That means 10 pins are standing. This is what we have. Now if you want to show this little graphically, in the sense you want to display it here, we are going to use dot join function. And look at this dot join. Now this dot join we are going to use once again when we do all our throwing of the balls as well. So we say put it I, capital I, if pin is equal to 1, equal to, if pin is equal to 1, currently all are 1, so everything will be I, and we will get 10 I's basically. And here I have just kept it space I, there is you can see the space also here. This is the space character, space is there, and then there is I. So space I, if pin is equal to 1, else if pin is already fallen pin, then you say space dot, so that it gives a good result. In a sense, you get a space there. And how many times we have to do this? For pin in pins, right? So this will be iterated, and you know that if you print this one, final, the initial state of the pins, here it should be initial state of the pins, and I have stored the result as begin. What will the matrix there? It will be 1 1 1 I for 10 times. Now what we have to do, we have to see how the balls are going to make the pins fall one after another. Now we have all these 10 pins are standing. Now we will throw the balls. Now we have 2 balls, and now this we are going to put it in a loop, process each ball. So look at this, for I is equal to, for I in range k is number of balls, in this case 2. So this loop will run for 2 times, I is equal to 1, I is equal to 2. Now I want to say which ball it is going on. So I just say print ball is equal to I plus 1, because I begins with 0 here. So I plus 1, ball is 1 here. And I want to say which all pins they have fallen. So say in this case, second and third pin is fallen. So I will say the second pin is fallen and third pin is fallen. But now look at this, in Python, because the indexing begins from 0, although the second pin is fallen, the index, the position will be -1, because indexing begins with 0. So I will say start, enter the starting position of the pin, and the start value will be whatever is the fallen, in this case 2 minus 1, so start will be 1 here, but indexing begins with 0, so position will be second, however number will be 1. And I will say what is the end, how many balls have fallen in your first throw. I want to say second and third ball has fallen, so start is equal to 2, end is equal to 3, and again I will repeat this for and now remaining, okay, so for these 2 positions what I will say, these positions will be marked as, the pins are already fallen down, these are marked as 0. So now what nice matrix has become 1 0 0, and then 7 times 1 1 1 1 1 1 1 1. This is my position now at this point of time, when I have already rolled the ball 1. Now I go ahead and roll ball 2, and now in this case what happens, say 6 7 8, these pins are fallen. First ball, pin number 2 and 3 have fallen, and now second ball 6 7 8, these pins are fallen. Then I will enter again when it reiterates, ball number 2 now, start I will say 6, end I will say 8, and remaining will be marked as 0 by the next for loop, and that's it. 2 balls were done. This loop has already done for 2 times. I come to the result, and result again the same dot join function, space I if the pin is equal to 1, else space dot if the pin is not 1, that means pin is fallen, that is 0 for pin in pins, and that's how I display my final result. Okay, so let's go ahead and do this one now. So how many number of pins? 10. Balls 2. Now I got this position. See, these are the 10 eyes. That means all these 10 pins were standing initially. Now I come for, because there are 2 balls, the ball, first ball rolling, I come, ball 1 rolling. Enter the starting position, which all balls have fallen down. So in our case, ball number 2 has fallen down, ball number 3 has fallen down. This is done for ball 1. Now we come to ball 2. Ball 2, what has happened? 6, 7, 8, these 3 balls have fallen down. So starting position of falling down of the ball, of the pin is 6 and then 8, and I get this now. Look at this. 2, 3 is fallen, 6, 7, 8 pins are fallen, and my final position will be I dot dot I dot 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 I. This was my initial position, and this is my final position after rolling the ball 2 times. Okay. Now it is not necessary you have to take 10 and 2. You can take 250 pins and you can take 12 balls, and you can just do it and it will give you the output in that fashion. So this is program 18. So this is how we have done program 18. Okay, program 19 was not run, so let's run the program 19. Let's enter. So let us enter the time. So I will say H1. Okay, so here let us run this code. Enter the first timestamp. H1 is say 7, 15 minutes, 15 seconds, and I want to say 8 o'clock, 15 minutes, 15 seconds. Now you know the answer. It is exactly 1 hour apart. What is the time difference in seconds? 3600. So we just calculate it and say time difference in seconds is 3600. When you are doing this program, you can always say time difference in hours, minutes and seconds. That also you can do as a variation for this particular code. Now we come to the program number 17, which is the last program of this lab 5. What is this program? Program to find length of the widest fragment where all elements are equal. That means we are going to ask user that enter the number. So user will enter 1, 2, 2, 1, 1, 1, 4, 7, 9, 9, 12, 12, 1, 2, 12. And we want to find out a fragment where the same number is repeated maximum number of times without it getting hit by another new number, right? So this is what we are doing. So for this we have to initialize the variables. We initialize 2 variables, current count and max count. So current count we initialize equal to 1, max count we initialize equal to 0. Current count is going to count of the current fragment, whichever fragment we are in. As soon as the new number comes in, new fragment starts, and current count will be transferred to max count, and we will be comparing between current count and max count. And this is how we will do until when? Until the user enters the number 0. As soon as user enters the number 0, we are going to stop the program and we will give the output. Okay, so now let's go here step by step. We initialize 2 variables, current count is equal to 1, max count is equal to 0. Now we ask user to enter the number and we store the number as previous number. Okay, so we have to check always the current number with previous number. We have to begin the previous number. So the first number is stored as previous number. Now in this code, if you enter the first number itself 0, then it will not immediately break. It will break for the second 0 in case if you enter the first 0. Okay, so we assume that you are not entering the first 0 and you begin with some number, because you want to, we say that enter any number and 0 to stop. So you don't want to stop when you are beginning. And now we are writing a while loop. Look at this, while true. So when you say while true, you are actually writing an infinite loop, right? But we will say as soon as the number entered equal to 0, you break the loop. Look at this, look here, this break. So break statement will break the loop and will come outside of the loop. But currently when you say while true, it is an infinite loop, always going to iterate and ask for the values. So now we again say number is equal to enter the number 0 to stop. So again the enter number will be entered. If number is 0, we say what is the max count is equal to max between max count and current count, and the program will break and you directly write the output. But if the number is not 0, then we will check the number with previous number. Say previous number was 1, entered number is also 1, then we will increase the current count by 1. Current count is already stored as 1 here, and now at this point current count will become 1 plus 1, that is equal to 2. And what will happen is we will say max count is max between max count and current count. Max count is 0, current count is 2, so the max count is 2 in this case. And this is we are going to do if it is number is not equal to previous number. We again enter the number and again check. If it is 0, you break the loop. If it is previous number, then we add the current count. If it is not previous number, then what we do, then it will come here. Max count will be stored as current count because that is the max between in this case, and current count will be restarted as 1 because the new number has started now entered, which is like entered number was not equal to previous number. The new fragment has started, and therefore current count we put it as 1, and we continue the loop until we enter 0, and then we find out what is the maximum count. Okay, nice program this is. Please go through the recording 1-2 times so that you understand what the program is all about. So we go ahead with execution of program 3. Right. So we enter the number. We'll just go ahead and execute this. Enter the number 0 to stop. We enter 1, 1, 1, 1, 2, and there is some problem here. Is it code? Okay, this is the problem. Max count, max. Okay, yeah. So let's run this again. We run the code. 1, 1, 1 3 times. No, I mean enter. I have to do enter. 1 enter, 1 enter, 1 enter, 2 enter, 2 enter, 3 enter, 4 enter, and we know now we'll close it here 0. And how many times? 1 is done for 3 times. So thank you very much. Please revisit these codes once again if you need to revisit, and we do these 4 problems as lab 5. Thank you.